Hi everyone, in this video we'll be learning how to find the domain and the range of the composition of two functions. So in our previous video, we have learned how to find the formula for the composition of two functions. So let's use the previous two functions again, fx and gx, the same formula for each of them. And now we're going to find the domain and range of gfx. So initially, our previous video, we have found that G domain of X GF X is given by the formula 1 over X square plus 1. So now how do we find the domain? So finding the domain, we will use this formula. So domain, I will put it as domain G F X can be written as the, so I'll put domain as, again, domain fx. So it will be the inner graph here. So domain of f x. So for this, we can see that the domain of fx is just any value. So it will be any real value. As you can see, let's think of negative values. When x are negative, you, this will fit in. There will be a definite value. And when x is 0, there is also a definite value, which is 1. And when x is more than 0, there is also a definite value for fx. So hence, it's this minus infinity to infinity. So we have already solved our domain for gfx. Now for the range, we just plug in the range, the domain, the domain interval here. So okay, now when x is negative infinity, okay, let's think of value. Let's say when x equals to minus 8, and therefore, oh, sorry about this. We can, to cut this short, we can use a graphic calculator, and we found that this will be a quadratic graph. Sorry, not quadratic. It will be in the form. So when x equals to 0, g f x equals to 1. So for the y-intercept, so when x-intercept, so when x equals to 0, y equals to 1. When y equals to 0, there is no value of x. So therefore, y can never be a value. And let's say we get a graph like this. So now, see how it goes. So now the range can be written as, so for here that if we see that if we put in any values of x, let's say when x is to the, sorry, it's our graph here. So when x is negative, let's say minus 8, so this will become positive, and this thing will become positive, so you get a value around here. And when x equals to minus 4, this will be smaller, so and when the bottom, when the denominator becomes smaller, the whole thing will be bigger, so it will be here. And when x equals to 0, y equals to 1. So you get a graph like this. And the same goes for this. Let's say when x equals to 8, you get it somewhere here because this is already large. And when x equals to 4, this is getting smaller and your output value will be higher, so it's here. And for this, so when x is equal to 0, this equals to 1. Then when x equals to 1, this will be smaller and this will be like half. So you'll get a graph like this. And you notice that it does not touch the y-axis. Why did I say so? Okay, let's say for this one, let's say if I were to put my output value as 1 over x squared plus 1 equals to 0, I can see here that I have no values of x, so therefore the output value cannot be equal to 0, must be more than 0. And when x is more than 0, the output value becomes less than 1. When it's less than, x is less than 0, the output value is less than 1. As you can see here, this is 1. So therefore our range can be written as, so not inclusive of 0, so this bracket 0 and inclusive of 1, so hence we will write in this form. So this means our range values is more than 0 and less than or equals to 1. Hence this will be our range. And we have already come to the end of this lesson. If you have any questions, please feel free to drop me a comment and I'll reply to your comment. Thanks so much for watching and have a nice day.